Welcome to IARE YouTube channel. So this is Professor Venkatachalapathi, Institute of Aeronautical Engineering. So I would like to discuss about pattern allowances and what are the concept of pattern allowances, types of allowances, and some of the problems related to for gate examination. And after completion of this video, you can able to understand clearly how you can able to determine the pattern allowances, how you can apply in the designing of the problems. Okay, so as you know that the term pattern can be defined as it is the replica of the original casting. So or whatever wanted to make a complex shape or a component, you are going to do some replica. Original shape can remodel and prepare the pattern. So this is a larger in size when compared to the final castings. Especially you can see some of the components which is related to pattern. So one we can call it as a plaster mold, one ceramic, one plastic. So pattern can be made with the different materials such as wooden piece and plastics or ceramics or other materials also. So in general, whenever a complex shape part which can be made with the metal casting process. In this case, what will happen, especially the complex shape like engine, okay, a four-wheeler or two-wheeler or any tractor engine to be made with the help of metal casting process. The complex shape of the mold can be prepared with the pattern. Okay, so based on that pattern, when you wanted to have a quality, do you have a good dimensional component? Obviously, you need to have some effect of this component based on the preparation of the pattern only. So when you wanted to prepare a simple shape, means casting not preferred. Whenever the complex shape only, the same size can be done with the help of this pattern. Once the pattern is prepared effectively with the help of some designing process and CAD, CAM and CNC machines to be used to have some good dimensional accuracy component can be manufactured. Now let us see majorly when you think about the pattern allowances. In general, there are pattern allowance will be kept for different materials. It can vary from the material to material. So in general, all metals will shrink except bismuth. So parallelly, you can see the various characteristics. So various characteristics of the properties like machinability, wear resistance, strength, and weight. What you call repairability, resistance, and swellings. All these are some of the properties where you can able to do. Either you can see the wooden piece pattern, how we can able to provide. So either it may be good or excellent or fair or poor. So the rating also should be important depending upon the material. So wooden piece pattern, so depending upon the characteristics, it can be varied. For example, if you see the machinability, when a component have a good machinability, it should have, when you use the wooden piece pattern, excellent machinability can be obtained. When you take into the aluminum is some good, there you can't get some excellent. Suppose if it is a steel means fair, the steel means fair. Plastic means also good and cast also good. Only whenever if you treat that machinability property, only wooden piece pattern can be used. We can have an excellent rating may be obtained. Similarly, wear resistance, the highest possibility is that is good is in aluminum. So even wood also very poor wear resistance, and excellent is the steel. So if you take the strength part, the highest maybe the three aluminum and plastic and cast iron good, and whereas wood is very very poor. Okay, so like that, repairability, resistance to swellings and all, depending upon the material, it can be vary. Even if you see for the swellings, wood is very poor, can be obtained, and if it is aluminum, excellent, can be obtained. If it is a steel means also excellent, plastic also excellent, cast iron means excellent will be obtained. So these can be collected with the source of DCEK and Winner, Introduction to the Foundry Technology, New York, Mike Grahal textbook I have collected from the 1958. Source is 1958. This information as collected in this textbook. Okay, that is the source for the textbook. Okay, and as you know that the pattern is the replica of the original casting. Why you wanted to provide the allowances? So generally all the metal shrink except bismuth. Even if you wanted to take a wooden piece pattern, so when you make a mold making, by pouring the molten metal, it will be able to shrink. Okay, so that is why how much amount of allowance should be applied, that details can be discussed one by one. Let us see what are the various types of pattern allowances. So these are the one of the most interesting pattern allowances, and also as per the examination point of view also, these are the general routine question they may ask in the your semester examination. So why? Because for whenever the casting means, the first and foremost things, what is pattern and types of patterns and what are the pattern materials. Just apart from that, when you are thinking about the designing, while performing a designing of the thing, obviously the pattern allowances plays an important role, and at the same time, before going to understand the designing aspect, you need to study the shrinkage allowance or contraction allowance, machining or finishing allowance, draft or taper allowance, okay, distortion or chamber allowance, shake or wrapping allowance. Okay, so these are the 5 different type of allowances to be important, where you can able to discuss one by one. So whenever I have explained the shrinkage allowance, all metals will shrink at least if it is a 100 mm size. So for example, there is a component, a rectangular component here, 100 mm. 100 mm is the size. When you wanted to, if you are to get a 100 mm part, you can add 2 mm plus or minus for the shrinkage allowance. Suppose if you provide the pattern size is 100, after getting the component, it may reduce into 98. Okay, that 1 mm is the reduction for the shrinkages allowance. That also we'll discuss. In general, the shrinkage allowance is mm per mm. So the unit for the shrinkage allowance will be mm per mm. So sometimes it may be mm per meter. So meter also will be there, this allowances. Okay, so this what about the shrinkage allowance. And the machining allowance, after the completion of the component, some extra runner riser, some finishing to be done. Obviously the finishing allowance also made to commonly, depending upon the material to material, it can be vary. So when the draft or taper allowance, so whenever the component can kept vertically in a mold cavity, when you remove the pattern, that mold cavity walls will break down. So that case, you can keep it in a some tapered form, that is what about the where you can able to have the easy removal of the pattern. You should apply some draft. The draft will be either inner draft or external draft, either 1 degree or 3 degree of inclination should be kept for the draft allowance. And distortion and camber allowance is nothing but where you can able to do some shapes, some shape of the components, some distortion components, some bend type components, where you can provide this type of distortion allowance or camber allowance. And finally, shaking or wrapping allowance. This is also called the negative allowance. We will call it as negative allowance. We will call it as negative allowance. So let us see discussed in detail about the one by one. What is the shrinkage allowance? What is the machining allowance? What is the draft or tapered allowance and distortion camber allowance? The only one allowance which is a negative allowance is called the shake or wrapping allowance. Okay. Now let us discuss about one by one. What is meant by shrinkage allowance? Okay, so this is what, let us see. The term shrinkage can be defined as whenever you can pour the molten metal into the molten cavity after giving the solidification time, it able to shrink. Okay, so in general, all metals will shrink. All metals will shrink except bismuth. Except bismuth material, it cannot shrink. So that is a one important point in GATE. Okay, so sometimes in the during 2002 or 3 in that year GATE examination, they asked all metals shrink except which material. So they will ask some 4 material. There bismuth is the suitable answer for that GATE. One mark question comes from that GATE examination. That is why you need to understand clearly why you have to provide shrinkage allowance, what is the importance of shrink, and either it may be contraction or volumetrically it will expand or contract. Okay, sometimes you can add for a hollow portion, so you can improve, and for solid outside external means you can add more. Okay, and again it can be classified into 2 or 3 types: liquid shrinkage, solid shrinkage, liquid solid shrinkage, etc. So when speaking about the liquid shrinkage, it refers to the reduction in volume when the metal changes from liquid state to the solid state. It refers to the reduction in volume when the metal changes from liquid state to the solid state at the solidus temperature. So in general, to account for the shrinkage riser which feed to the liquid metal to the casting that are provided to the mold. So similarly, when you speak about the solid shrinkage, first one is liquid shrinkage and second one is solid shrinkage. So in the solid shrinkage, it refers to the reduction in volume caused when the metal loses its temperature in the solid state. Okay, the metal loses in temperature in the solid state. To account for this shrinkage, allowance is provided on the patents. That is what, for example, 100 mm size to have a final dimension. Obviously, for depending upon the material, you can add 100 plus 2 mm for the allowance for the shrinkages. So when you wanted to get exactly 100 mm size, that pattern dimension should be 102 mm after applying the shrinkage. So that you need to understand clearly, and also various allowances also can able to understand clearly in the discussion of the allowances. While solving the problems, some materials they may give like some data book. Otherwise, some materials obviously you can supposed to remember the allowances for the steel and cast iron and aluminium and what about the various type of shrinkage allowance to be provided. Based on that only we are supposed to provide. Okay, so that is the importance of the shrinkage allowance. Next, these are the some of the dimensional allowances. Let us see some typical allowances. These information also collect in the P and R textbook. Okay, so whenever the typical allowances to be made, for example, if you see the cast iron, in the cast iron, it can be vary 0.8 to 1% of shrinkage allowances to be provided. Yes or no? So 0.8 to 1%. Sometimes even it can be vary depending upon the application. And steel, the steel can be provide the allowances. Shrinkage allowances should be 1.5 to 2.0 percentage of allowance should be provided for the steel, and aluminium 1 to 1.3. Aluminium 1 to 1.3 percentage of allowances to be provided while shrinkage of that metal. And magnesium 1 to 1.3. This is also similar. Magnesium also same 1 to 1.3 of allowances should be provided. So coming to the brass material 1.5 percentage of allowances should be provided for the doing a good sound castings. Okay, so in general sinkage allowances are incorporated into the pattern because of shrink rules. That is what shrink rules. It can be very liquid shrinkage and solid shrinkage. Liquid solid shrinkage is also okay. And some whenever the pouring the molten metal into the mold cavity, what will happen? Some thermal contraction might not be the only factor for determining the pattern size. Obviously, some finishing operations also like machining, grinding, and surface finishing, etc. We should to be considered for the some finishing allowances are taken into the consideration for the surface finishing, that is machining allowance also should be provided. Okay, so these are the some important allowance, dimensional allowances will be provided for the different type of materials like cast iron, steel, aluminum, magnesium and brass. Okay, so this is about the dimensional allowances. Next, coming to the machining allowance. What is meant by machining allowances? Why you should provide a casted product for the machining allowance? So machining allowance or finishing allowance, we can also call the finish allowance. Finish allowance. So let us see, a casting is given an allowance for machining because these are the some important factors to be considered. The castings get oxidized in the mold during the heat treatment, so that some scale formation, some foreign particle formation will form into the component. In order to remove some extra, even riser runner components also that can be removed, so that only you should provide some machining, some finishing allowances common to all the surfaces, either front, back, top and side, all the three surfaces you can add. So that is called the machining allowances. And sometimes it is required to achieve the exact casting dimensions. When you wanted to achieve the exact casting dimension, for example, you can see there is a component, three-dimensional, a cube component, so where you can able to have, so the size is 50 mm, height also 50, okay, and the side also 50. So whenever, so the serial number, so 50. Shrinkage allowance for the wooden piece metal. Suppose previously I have explained that you see cast iron 0.8 to 1%. You can provide 0.8. So that is multiplied by 100 divided by 1000. 0.8 into 100 divided by 1000. So to that is called 0.08. So 50. Shrinkage allowance is 0.08. The total 50.08 mm size of allowance should be provided in this machining allowance. Also, we can add some extra finishing purpose. Some extra amount to be done it. Okay, so this is what about the machining allowance or finishing allowance should be done. Okay. And another thing is how much extra metal or how much machining allowance should be provided depends upon the major factors. So that is first one is the major factors. First and important thing is it is a nature of metals. The first and foremost thing is the factors to be considered for providing the machining allowance is nature of metals. Nature of metals. So that is either wooden piece or ferrous or non-ferrous or ceramic, depending upon the materials or metals only, how much amount of allowance should be provided for finishing. And also size and shape of the castings, either it is a rectangular shape or circular shape or triangular shape or any polymeric shape. For that reason also how much machining can be provided. and the type of machining operations to be employed for. So that is what type of machining operation. Either when you perform the metal removal, lathe or milling or drilling or shaping operation, which type of machining operations can be performed. Based on that also some extra part can be eliminated by providing some size. So for example, if you say a component having, so this is a total 100 mm, this is 60 mm. Okay, so whatever the allowances should be provided to have it. So here 100 means by removing the some 1 mm, 2 mm based on the type of material only can remove the material, and similarly 60 means also how much amount can be eliminated in this case. So whenever any component, obviously they need certain finishing, surface finish should be done. Obviously it can be very minimum 1 mm, 2 mm, 3 mm, 5 mm depending upon the requirement for the application you can do. Okay, so this is what about the machining elements or finishing elements. Next, let us see, this is a draft or tapered allowance. So this is one important and interesting one. So whenever, so the pattern is like in a vertical, okay, in a square frame. So the same thing if it is a mold cavity like that you can prepare. Okay. These are the sand, okay, dry or wet sand. Similarly, how we can able to provide. Okay, so whenever that hollow portion, so the shape, if it is a vertical means when you removing, after remove, this is a drag box, cope box, drag box, cope box. Suppose when the three-piece pattern can be used, there is a three different boxes to be used. One drag, one cope, and another is called cheek box when it is a three-piece pattern. But whenever why you wanted to apply tapered means easy removal of the pattern. If it is a vertical condition, it is difficult to remove the pattern. So while removing, these walls may be break down. So that is why you can able to provide some tapered surface. So this is the vertical surface. So you can easily remove of the pattern. Obviously you can apply the some taper or draft elements. Either this again can be classified into internal draft and external draft when it is a hollow portion. So when it is a inside, if you provide some core, so there you may get so there how we can able to remove the pattern from the hollow portion. So the draft taper allowance can be defined as it is given to all surfaces, particularly in a vertical line, parting line above. When it is a vertical, obviously you can able to put some draft allowance for easy removal of the pattern, where draft allowance is given to so that the pattern can be easily removed. That is what I have been explaining. Easily removed from the molding material, tightly packed around without damaging the mold cavity. So wherever the mold cavity should not be damaged means if you provide the some draft allowance. So obviously pattern can be easily removable. So and also the taper, why the taper should be provided. This basically depends upon the first and foremost thing is shape and size of the pattern in depth. Shape and size of the pattern in depth. Direction contact with the mold cavity. So direction in the contact with the mold cavity. Molding methods also will be provided. Molding methods should be provided. Mold materials also you can able to understand, and draft allowances is imported on internal as well as external surfaces. Of course it is more internal surfaces, okay, more on internal surfaces. Draft or taper allowances, the main purpose is for easy removal of the pattern, okay, from the mold material or molding material. That is called draft or tapered allowances. Okay, I hope the student can understand clearly about the draft or tapered allowances. Next, let us see what are the design consideration So for any product design, you should able to understand, you should able to give some consideration for removing some finishing, like that. Even some bend type shape also, how what type of allowance should be provided, these things should be remembered for the examination point of view. So the main guidelines for the product design is, you should able to draft guidelines. First of all, you should able to draft the guidelines. In expendable mold casting, draft facilitates the removal of the pattern from the mold. So this is what I have been explained. So if you are not providing taper, definitely you can easily cannot be this. If it is in a vertical condition, if you remove means obviously the mold cavity will be breakdown. Okay, mold cavity will be breaking. So that in order to avoid that, you should maintain some 1 degree or 2 to 3 degree for the allowance. Okay, for tapered or draft allowance should be provided. Okay, so in a permanent mold casting, the purpose is in A to remove a pattern from the mold, that is draft should be 2 to 3 degrees of the permanent mold process. Similarly, for what you call 1 degree for the sand casting process, 1 degree for the sand casting process, and similar tapers also should be allowed if the solid cores are used. Whenever the core can be defined as making the hollow portion. So even the hollow portion, when you wanted to have the casted product in a whatever say specified in the roll manner, so obviously here you need to understand clearly the taper should be allowed if the solid cores are used. Okay, so whenever the core is the making the hollow particles, making the hollow sizes, so obviously the cores can be most widely used in pattern allowances. Look at the draft allowances for the various metals. So this is what another interesting subject, where you can able to determine what are the pattern material. Okay, and how the draft angle. Okay, draft angle for internal surface, draft angle for the external surface. So for example, you can see if you select the wood piece pattern, again it can be subdivided into height of the given surface, and draft angle external surface, draft angle internal surface. Okay, external and internal surfaces. So while applying this draft allowances for the various metals. Okay. So coming to this, some technical composition or some important point should be remembered whenever the wood piece pattern. Okay, wood piece pattern material can be used. So obviously the draft for external is 3 mm, and if it is internal means also 3. But only thing is at the end you may get the lot of benefit. Okay, benefit by removing the pattern easily. And suppose if you choose the metal and plastics, in general metal and plastic means for height of the given face is 1 means 1.5 for external and 3 mm for the internal surface. This is what about the metal and plate are most widely used for doing these draft allowances. Okay, look at how the three-dimensional diagram, how they can kept in this academic institution or manufacturing technology lab. Okay, there is some foundry lab is available there. You can able to see clearly how you can extract the mold cavity. Okay, how you extract the mold cavity easily. So look at the draft allowances. How the draft allowances is very very important. Why? Because when you speak about this pattern allowances having the no draft in the internal edges, so whereas in the vertical surfaces only you have an internet understanding. Okay, so here what I wanted to explain, the pattern having draft on vertical edges, whenever the pattern should be a vertical position. Obviously, what you are doing to do, so this vertical face, wherever the vertical face should be in a taper form. So whenever the vertical means, you can able to put taper. Okay, so like this you can able to understand clearly, and this type of pant, what you called pattern having the draft with the vertical, wherever the vertical surface is there, you can provide some draft elements. So you can see the clear understanding of the, without applying draft, there is no draft is there. How we can have, this is the comparison between the first diagram to a second diagram. So in the first diagram there is no draft, okay, and a very less amount of draft will be there. In the second diagram which will shows the pattern and parting line and etc. You can able to have some pieces, okay, some patterns having draft and impacted what you call edges, vertical edges. Wherever the vertical edges are there, you can apply the some taper, and also that how do you provide the various type of allowances in the pattern making department. Okay, and look at the how the design in a taper. So just you can compare how the design in a good. Okay, so this is very good. Why? Tell me anyone. You can tell me the taper in design. If it is a vertical component, you can pour all those things. When you wanted to remove, there will be some taper should be there. So that is what you can observe here in the left side diagram. There is no application of the, okay, no application. Okay, whenever it is in a vertical, obviously you can keep the some taper shape so that easy removal of the casted product. Okay, now the fourth and interesting one is a distortion and camber allowance. Distortion and camber allowance, for example, you can see some bend shaped components. Bend shaped components may be preferred for the, okay, some bend shape, and also like this. Okay, so like bend shaped allowance, which is also called the cambered allowance. A casting will distort for wrap if it is a regular shape. If it is in a regular shape, air parts, all the oil, what you call the distortion camber allowances can be defined as whenever there will be a distraction, and why it has been, once you have to perform the wrapping. Okay, so obviously this defect also will be exist here. The it is the regular shapes can be done by with the distortion elements. All its parts do not shrink uniformly. That is what I have been explaining. All parts shrink except bismuth. Some parts shrink while others are restricted to during so. So if it is a U shape or V shape, if it is a some U shape or V shape, these are the very important terminology where you can able to do. Okay, here what you call all the parts do not shrink uniformly. Some parts shrink while others are restricted from during so. So it is also we can call U or V shape. Okay, the arms possess unequal thickness. Arms possess unequal thickness, and it has long rangy arms for this propeller shaft for the shift. And obviously this have a one portion of the casting course cools at the faster rate. Obviously you can able to understand this distortion or camber elements. Okay, and let us see now. Let us discuss one simple problem related to metal casting process. How do you apply all the important formulas, and how do you get the important answers during the GATE or any competitive examination. Okay, so let us see the problem. Problem number 1. A job is shown in the figure is to be made. So this is what about, this is called a job. Job is some 100. Okay, so this is the 100 size, and this is called 20, and this is called 50. Okay, so approximate you took the dimensions for solving this problem. So 100 200 and 50 So length, width, breadth. So any cubical shape, okay, there must be a length, there must be breadth, there must be a thickness. How do you do these type of problems effectively? So here, let us read the problem. A job shown in the figure, what you called a job shown in the figure. This is the some rectangular component is to be made of steel by casting process. It is made of steel by casting process. The mold for this job is made from the wooden patterns. Absolutely. Okay, here the wooden pattern can be used widely in order to have the good dimensions. And another thing is determine the dimensions of the wooden pattern. What are the what you call dimensions of the determine the dimensions of the wooden pattern. Assume here machine allowance is 2 on each side. So machining means at the end only machining allowance. So this is how many members, what you call the determine the dimensions of the wooden pattern, assuming the machining allowance of 2 on each side. Shrinkage allowance is 2% and tapered allowance is 1 degree. So let us see. So the job which is without applying, okay, so in this figure made up of steel, okay, mild steel in the casting process. The mold for this job is made from the wooden pattern. So the pattern should be wooden pattern, okay, wooden pattern, okay, and determine the dimensions of the wooden pattern. Okay, assume machining allowance also take 2 on each side. And how we will determine the dimensions of the wooden pattern? Wooden pattern, I assume the machining allowance of 2 on each side, shrinkage allowance is 2%, and taper allowance is 1 degree. So for example, if you see, this is the, by applying shrinkage allowance for the metal, steel is, for example, 0.0015 micrometer. Okay, so 0.0015. Okay, so suppose 100 means you can able to apply. So this divided by what you called first you should provide the shrinkage allowance. Shrinkage allowance, why you wanted to provide? Okay, in this type of cases, shrinkage allowance for a steel, you can see the steel, shrinkage allowance steel is 1.5 to 2 1.5 to 2 okay, and majorly the amount of taper depends upon the 4 major important factors. The first and foremost thing is the shape and size of the pattern in the depth, and direction in contact with the mold cavity, and molding methods. Molding methods also one most important thing. Either we are doing hand molding machine or machine molding machine, that is also to be understood clearly. And mold material, the material in such a case, wood piece pattern, ceramic and steel. Okay, depending upon our application usage, and we can able to understand the clear of the tapered allowance or draft allowance. Obviously, for external draft is 3 degree, internal draft is 1 or 2 degree. Okay, so this is what about the draft allowance. The term draft allowance is imported on internal as well as external surfaces. Of course, it is more on your internal surfaces. Okay, so what I suggested here, whenever the component is in a vertical position, obviously you can able to keep some taper. Otherwise, the last of lot of wastage in the sense molten metal preparation, that again once again it will be cool, and again once again you can do the heating. So draft allowance is imported on internal as well as external surfaces. Of course it is more on internal surface only. So the why because this is more on internal surface. Okay, it come more than the internal surfaces. Okay, and let us see the product design and consideration. So in the right side diagram, how we can able to draw the sketch. Okay, so these are the some similar tapers also can be allowed if solid cores are used. Okay, similar taper should be allowed to solid cores to use it the some what you called for similar taper should be allowed if solid cores are used. Okay, so this is what about the product design consideration while performing the gate problems, competitive examination forms, etc. And another interesting thing, these are the table also connected from P and RAW. So where different type of material to be used. Okay, so for example, if you say wood piece pattern, metal and plastic pattern, because of height to the given surface, draft angle, either it is external draft or internal draft. Okay, and what you called internal surface and external surfaces. External surface in the sense what you call draft angle external surface, and internal surface means where you can able to attract the food. Okay, this is what about the draft allowances of various metals. It can be vary for inches. For one means external draft allowance is 3 and internal draft is 3. And one more thing, the 1.5 is the draft angle external for the wooden piece, 2.5 for the what you called internal draft. So similarly, it can be vary material to material. For wood piece pattern, it is very difficult to identify, and for metal and what you call metal and plastic material can be used. You can obviously where either you can provide the internal draft or external draft. In case you need to understand, whenever the piece is and vertical, okay, obviously you can able to provide whatever class. Okay, so this is what about the allowances, draft allowances for the various metals. And similarly, you can see clearly how the pattern will be kept and you can able to obtain in these cases. So this is a right one 3D diagram. How they can see it is in vertical shape, and whenever in the shape you will get some tapered shape. Whenever by putting the tapered shape, the pattern can be easily removed with the help of the draw spike also. Okay, so this is what about the some important types of allowances and how do you solve the problems with the simple. Okay, we'll discuss one by one. And this is another taper in design. So especially when the starting itself taper in design compared with which is the good design, which is the bad design. So the second one is the how inside the mold should be kept to taper, and obviously due to this the component can be easily removed by this technique. Okay, so this is what about the taper in design. And distortion and camber allowance is nothing but it is also called the irregular shape and do not shrink uniformly. Some parts shrinks while others are restricted to form doing so. Okay, so especially distortion and camber allowance is either it may be U shape or V shape. Okay, the arm possess unequal thickness. The arm possess unequal thickness. Arm possess unequal thickness, and it is a U or V shape. Okay, the arms possess unequal thickness, and wherever if it is a long flat casing, one portion of the casting tools are faster than right. Okay, and let us look at the problem for the. Okay, so here what is the given data in this problem? Okay, so given data. Okay, so in the what is the given data is given first a job figure, say like this. Okay, and the mold for this job made from the wooden base pattern, determine the same what you call determine the dimensions of the wooden pattern. I assume here machining allowance should be 2 mm on each side, and what you call shrinkage allowance is 2%. Shrinkage allowance also 2%. Tapered allowance is 1 degree. Tapered allowance is 1 degree. Okay, so how you will do this problem means, first of all, what are the all metals will shrink except bismuth, and here you can see this distance you can able to. Okay, so in this case 100, and this you can say 80 mm, this is 20 mm. If you draw a table, serial number, and here three different 100 mm, 80 mm and 20 mm. Okay, so initially you can apply the shrinkage allowance and draft allowance and what you call bend or distortion allowance. Okay, so look at for by adding 100 plus plus or minus to this 104 is the shrinkage allowance, and draft is 1 degree 2 mm. Okay, so whenever the tapered allowances are 1 degree, so by adding again it will get 106, and machining or surface finish operation you will go through this what you call tapered draft allowance and shrinkage allowance, and tapered allowance is 1 degree. So this is draft allowance or machining allowance or finishing allowance. Machining allowance and draft allowance. Similarly here 80 plus 4, and this is 80 not 6. Okay, and even 20 also 22 and 8 not 8, and finally total allowances will be, you can add all those things 104, and totally here 4 mm 2 mm 6 mm and plus 2 mm 2 mm. Okay, so that 104 106, and finally what is the amount when you can purchase that is what about this simple allowances problem for solving the simple technique. Okay, so in general for shrinkage allowance, if you give the some 2% means 2 by 100, that is equal 0.02. Okay, so there you can 100. Okay, so length is 100 into 0.02 divided by 1000. Okay, so 2 zeros cancel and one more 0, so that is equal to 0.002 mm per meter. Okay, mm per meter. This is the way you can calculate the shrinkage allowance. At the same time, the other side dimension 80 mm and other side 20 mm. And whenever the draft allowance should be considered, you should have some taper. Some taper should be maintained. So then only you can able to understand. Okay, and machining or finishing allowance in the sense whenever some extra particles and some particles will be occur, that can be eliminated by this machining allowance or finishing allowance. Okay, so I hope the students can understand clearly. In the next session we will discuss some more important related problems, etc. Okay, so thank you for this session.
Like, share and subscribe. Hit the bell icon for more updates.